Hey there! So we know already what a data lake is, that it is meant to store files. But actually, what type of data files are there? What file types you will use in your career as a data engineer? So today I would like to talk about 3 common file types that most likely you'll have to work with. So let's get started. Now, there are a lot of different file types, plenty of them. And obviously we won't be able to cover every one of them because it's simply not possible. So today I would like to focus on 3 quite common ones. And actually, let me start with, I would say, the most common one, at least from my point of view. That is a CSV. So let me write it down. CSV. So it stands for comma separated values. Comma separated values. And every data engineer sooner or later will have to work with CSV files. So it's really important to understand how they are constructed and what you have to take care about when you are working with them. So CSV stands for comma separated values. And now, when we think about these CSV files, you will see in a second that they are just text files. So very simple, very easy to create. Basically, every tool can be used to open them, and I will show you it just by creating a brand new CSV file using Notepad++. So, in case of CSV files, usually the first row we have is a header. And header simply indicates what columns we should expect in our file. So let me just create some dummy file like that would have columns such as ID, name, title, salary, and birth date. So let's assume that this file is meant to store employee data. And this header, this first row, it indicates that we'll have, or that we'll expect, those 5 columns, like ID, name, title, salary, and birth date. So pretty simple so far. And then every row inside our CSV file, it represents a separate entity, separate row. So for example, the first row would have ID equal to 1, name, let's say Piotr, title architect, salary, let's say 100.5, and birth date, some dummy date, like this. So that's the first row. Let's add a second row, like Tom, that is a data engineer, that has a salary, let's say 80, and a birth date like this, and so on. So based on those 2 rows, you should already see how this CSV file is structured. That actually it's quite easy, just by looking at this data, to understand what it contains. And basically every tool out there, including something as simple as Notepad, is able to open a CSV file. So actually, let's write it down, that CSVs can be opened by practically every tool out there. And that is a benefit for us, because we don't need any specialized software to work with CSVs. And that's not always the case, because later on we'll talk about some file types that you won't be able to open using Notepad. But CSVs are pretty simple, so they can be opened by any tool. These are just text files. And what we saw already, they are pretty simple and easy to understand. At least that was the case of this employee file that had only those 5 columns and 2 rows. So it's just by looking at this data, we already know what we were trying to store here. All right, but actually, it's not that simple in case of CSVs, because there are some watchouts that we should pay attention to. So for example, let's take a look at our data. So CSV, it is just a text file. And there is no way to enforce a schema. All right, we have this header defined in the first row that specifies what we expect to have in the file, but there is no schema enforcement built in into this CSV file format. So it might be the case that we might get a file like this that would have more columns than we expect, because the file format by itself, it doesn't restrict it in any way. It's just a text file. Similarly, we might have a row that contains like rows like this, only 3 columns, so we are missing 2 of them. And again, just by using CSV file by itself, there is no way to enforce this stuff. Secondly, based on the values we have, you would expect this ID column to be numeric, that it's just some kind of a number. But again, in the case of CSV, everything is just a string, so we cannot enforce it in any way. And one day you might get a file that would have just a word here instead of a number. So later on, when you will be trying to parse this file and convert those ID values into numbers, into integers in this case, it will fail on this 3 value. But again, that's just how CSV file is structured. So everything is a string and there is no schema enforcement. So let's write it down. No schema enforcement. And everything is a string. Every column is a string, even though that we know that a given column should be an integer, date, or some number, decimal. No, in case of CSV, everything is a string. There are no types defined inside CSV. So everything is a string. Which means that if everything is a string, then you should pay attention to your data, because you cannot trust your CSV file that every column will have data of proper type. And unfortunately, in many cases, you will have to work with CSV files that are just bad, that they have some trash data inside. All right, so let me remove this dummy row and let's focus on this birth date column, like this one, this value. So actually, if I ask you what date it actually is it the 1st of February or the 2nd of January? Can you tell? No, you can't, because you don't know this, just by looking at these 2 rows. Maybe if we had more rows in this file, then probably one of them would have a value bigger than 12. So it would give you a hint which part is a month, this one or this one, and which one is a day, right? But in this case, we don't know this. And again, instead of guessing the format, it would be great if we had the specification of the file. And in case of some data sources that you will be ingesting, some documentation might be available. If not, you will have to derive it based on data, or ask developers on the other side to provide those for you. So basically, anytime you're working with CSV, ask for metadata. You might ask a person, ask the internet. Maybe this is a file generated by some software that has structure well documented, or maybe there's a documentation available that you can check for those details. But anyway, you've got to ask for this metadata. And what I mean by this? So, for example, in the case of our dates, we would like to know what is the date format. So, for example, is it year, month, day, or something different, right? Because again, depending on the culture and the country from which you're getting your data, this date format might differ. So just to avoid these differences, ask upfront from your date format. Then, in case of dates or columns with dates and times, like timestamps, so instead of only a date, we would have an hour and minutes. What is very important is to ask about time zone, which was used to generate and store a given date or timestamp. And why? Let's imagine that you are ingesting data from different sources located in different areas around the world. And if each of them generates dates and times using their local time, then you can't just compare them. For example, to calculate how long it took for a given order to be delivered since the time the order was created. No, you simply can't do this. First, you would have to convert those dates to the same time zone, like UTC. But to be able to do this, you have to know upfront what was the time zone used for dates and timestamps. So let's write it down. So what was the time zone used? Like UTC, Central European summertime, and so on and so on. Then let's take a look at our salary. We would expect some number here. And again, the question is it a decimal value? Are we expecting decimals, values with some digits after the comma, or only integers? Now, looking at this example, we can see that the first row is a decimal. So probably we should treat it as decimals. But again, in case of decimals, what character is used as a decimal separator? Is it a dot, like in this case, or is it a comma? Again, different cultures, different nationalities will use a different way of writing numbers. So again, when you are working with CSVs and you're trying to get this metadata, ask for number format. How those numbers will look like. Because again, in case of CSV, everything is just a string. And inside the string, you can store everything. You cannot enforce in any way the proper format. Now, in case of salaries, sometimes you might get like currency in the front of your number. So again, it is to define whether this currency symbol is expected or not. Then again, in case of numbers, if we have some huge value, then you might have something called thousand separators, like this, 100,000 and a half. And in some cases, you might get this space as a thousand separator, or a comma, or maybe a dot, and then here as a decimal separator you would have a comma. So again, ask for this specification, just to avoid some nasty surprises later on when you will encounter a value that you didn't expect. I mean the format that you didn't expect. Then let's imagine that you are trying to store this data inside a SQL database, some table, and you would have to define the schema of this table. So think about all those things that you need to create a proper schema for a table, like data types. So again, you would have to know that, let's say, ID is an integer type, then name and title are strings. And again, in case of strings, it would be nice to know what is the maximal length of a given column, just to be able to define it later on, if there is such need, inside the database. Now, if you have enough data, you could just check the data in a file to see what is the max length of the given column. But it might not always work, because maybe the data you already have that you received in a file, it doesn't represent the all data in a proper way. And one day you might receive a file in which this name column would have longer value than you expected. And then it would either be truncated, so you would lose some data, or your process will fail. So again, ask for those column specifications, like max length, nullability, if that's possible. In case of numbers and decimals, if possible, ask for scale and precision. So basically, ask how many digits are expected to be after the comma. Like, is it only a single digit, 2 digits, or more? And secondly, how many digits in total your number can have? Just to be prepared up front for values that might be sent in some subsequent files. Now, once you have this, you might think, all right, I'm well prepared, so let's proceed with data ingestion. But actually, there are some things that you have to be aware of. So let's say that our first row, the Piotr, is not only the architect, but also an analyst. And we received such data that as a title, we got architect, analyst. And from the source system point of view, this is a proper value, because this given person, it has 2 roles. But actually, take a look. In a CSV file, we've got to define the character that splits our columns. And by default, and most commonly, character that is being used is a comma, hence the name, comma separated values. And you can see it here that every column, whether that's header or the rows with data, we used commas to separate our columns, and that works just fine, right? So actually, when you are working with CSV files, always you have to know what is your column delimiter. Is it a comma? And most often it is. Or is it something different? Column delimiter. Actually, it doesn't really matter what character is used. And I saw files that used like dollars as a column separators, or semicolons, or pipes. It doesn't really matter, as long as you know what character is used. and that the file is consistent and uses those characters across the whole file. But now, in our case, we are using commas as a column delimiters. But the problem is that our row has this value, architect, comma, analyst, that contains this comma inside. And if we started parsing these values into specific columns, it would work like this. So the first column would be recognized here, that the value of 1 is ID. Then the name would be recognized to have a value of Piotr. Then the title would be recognized as architect. Then the next comma would work like this, that the analyst value would be treated as a salary, which is not what we would like to do. Then this number would be treated as a birth date. And finally, this date would be treated as an extra column that doesn't have a header. And it all happened because we had this extra column, this extra comma inside our column, our value. And some developers say, all right, so in such case, let's switch our column delimiters to something different, like let's use a dollar symbol, because there is a pretty low chance that we'll have dollar symbol inside our data, like this. And no, that's not the way to proceed with CSV files, because one day you might have this dollar symbol inside your data and you'll face the problem again. No. So what we are doing in such cases is to use text qualifiers. And usually what we are using is double quotes. So it simply works like this. Every column is enclosed within those, in our case, double quotes. Like this. I will do this for the first column only, for the first row, sorry. But it should be done for every row. And then we would have to tell our parser, the software that we will later use to read this file, that in our case, text qualifier was set as double quotes. So we have to know what text qualifier is used. Text qualifier. And it would work like this. So basically everything that is between those text qualifiers would be treated as a single column. So in this case, we would have 1 as ID, Piotr as name, and then architect, comma, analyst as a title. So now this data will be properly read and parsed. So that's how you handle these cases. But then you might ask, all right, but what if we have double quotes somewhere in our data? Let's say that we have a nickname, the boss, inside our title. So in this case, we would like to have all those 3 values stored as a title: architect, the boss, and analyst. So how to handle this case? And here the rules are simple. If you would like to read some characters literally without this special meaning, just use escape characters, like those slashes, just before those characters. And then the parser would know how to treat those double quotes. That it should forget about the special meaning of it and just treat it as a double quote. And then, as a result, we would have the following value as a title. It would be architect, the boss, and analyst. So that's exactly what we would like to have. So it means that in case of CSVs, when we are working with it, for metadata that we would have to know is Yeah, text qualifier, it's already there. I already wrote it down. Yeah. And escape characters. Escape characters. What character is used to escape those special ones? And again, the most commonly used one, let's say default or industry standard one, is the slash. So again, you would have to know the specification of the file. And by default, or the most often used values are comma as a column delimiter, double quotes as text qualifier, and slashes or backslashes as escape characters. So that's what you have to know when you are trying to read a CSV file. But that's not the end. So let's take a look at this value in the lower bottom, this UTF-8 encoding. So basically, every time you are working with a file, you have to know how it was encoded. Why? Simply because you might have some letters, some characters that are special. For example, in Polish language, we have letters like those that are specific to Polish language, and they are encoded in a specific way. And now, if you receive a CSV file that you have to read and you use incorrect encoding, let's say instead of UTF-8 you would use ANSI, take a look what happened. We have some trash instead of our data. So encoding is extremely important. Otherwise, you might, and you will probably lose some of your data. For example, those umlauts like in German. Now, if you are not sure what this encoding is, UTF, ANSI, ASCII, then there's a great blog post that is quite old, but it describes it pretty well. That's the absolute minimum every software developer absolutely positively must know about Unicode and character sets. No excuses. And take a look that it was published like 20 years ago. So that's an old article, but really good. It will take you half an hour to read, but please do it, especially when you're working with CSV files. So we can add this encoding thing to the list of things you have to know about your files to be able to read them properly. So encoding. So it looks that there's quite a lot of stuff you have to know about your CSV file to be able to work with it. And yeah, that's true. But on the other side, once you start working with CSVs, you will see how easy it is, how common they are. Basically, every tool that produces data is able to extract, to export it as CSVs. Now, the bad thing about CSV file is that it doesn't really work in case of hierarchies. It allows for a flat structure only. So let's imagine that we would like to receive data about orders, like some sales orders. And every sales order has some order lines. And now if you would like to model this as a CSV file, then most likely you would end up with two separate files. One that would contain just sales orders, some kind of a header and identifier, and then a separate file with sales order lines that would have a reference to specific sales orders. And it is done this way because CSV files, they are kind of a flat files. They don't work well with hierarchies. So let me write it down. Those files are flat. But you will see that they're extremely common. Alright, so these were CSV files. Now, apart from CSVs, what you will probably have to work with, or that you will encounter one day or another, are XML files, like XML. So XML, it stands for Extensible Markup Language. So Extensible Markup Language. And now, if you know HTML, you will find XML kind of similar, because in both cases we use those markups and tags. But in case of HTML, we have to work with a set of predefined tags, while in case of XML, it's up to us to define what tags we would like to use. And now, actually, I will switch to Visual Studio Code to create an XML file. And it's not because it is so difficult to create it, no. It's simply because I have some extensions installed in my Visual Studio Code that makes working with XMLs easier. For example, if I create an opening tag, then Visual Studio Code will automatically create a closing tag. And let me explain how it looks like. Alright, so in the case of XMLs, we are working with tags, and tags are like in XML, like in HTML, use those angle brackets. So that's the starting or opening tag, and the one with backslash is a closing tag. So everything between those opening and ending tag is the content of our XML file. And XML files are used most often to exchange data between different applications, different systems. So let's say that we would like to model those hierarchical data that we just talked about, those sales orders. And I said that in case of CSV files, it is kind of difficult to do, but when using XMLs, it's pretty simple, because XMLs, they support hierarchical data. So actually, let me write this down, that XMLs, they work pretty well with hierarchical data. Alright, so let me start working with some sales data. So I have to create this opening tag, let's call it order, and that's what was created is an element. So this is called XML element. Now, apart from elements, I could add some attributes that would provide some extra information about this particular element. So for example, for order, I could create an attribute called ID equal to 1. That would clearly indicate that this particular order has an ID of 1. Then I would create some sub-elements that would further describe our order. Let me create some header element that would contain some information about the file, like, I don't know, order date. That would be something like this, or whatever. We might have some comments about the order in general, like super shop or whatever. Then we might have some order lines. So I would create this lines element, inside which I would create multiple line elements, each of which would represent a single line on our order. And when it comes to the content of our line, I might have something like this, like product ID, that would indicate what product was actually sold. I could have some quantity, like how many pieces of given product was sold, like 3 copies, what was the unit price, like 10, and so on. Then I could have multiple lines inside my XML. I would just update the value like this. And then one more. Let's product ID 34. And we bought like 39 pieces by $1 each. So basically that's how XML looks like. And again, just by looking at this syntax, you should be able to understand how it looks like, what I was trying to create here. And take a look that it's quite easy to see what is a parent of given element and which elements are children of given element, just by these indentations. So the hierarchical support is quite well done in case of XMLs. Now, what we can write about those XML files is that actually they are quite easy to understand. Once you become familiar with them and you will learn how to read them, easy to understand. And actually, there is some great feature of XMLs that we didn't have in the case of CSVs, namely schemas. For XMLs, we can have a schema that defines exactly what elements we're expecting to have, what data types that they should contain. For example, that our product ID is an integer, and for example, how many line elements we expect to have, let's say between 1 and 100. And then when we have such schema, we can take the file we received, the XML file, and validate it against the schema to see whether it conforms to it, whether it's a valid file. And actually, let me create some schema for this particular instance of XML. And there are some online free generators that are able to generate the schema. So I would just paste my XML into this window and then generate the schema. And in the output, what we have is this strange XSD file that defines our XML. So for example, we see that we should have a root element under which we would have a sequence of elements called orders that again should have a header inside which we would have an order date of a date type. Then we would have element called comments of string type, and so on. Of course, the auto-generated value, most likely it would require some manual updates, but that's a very good point to start working with schemas. And one warning to you guys, be cautious when sending data to those online validators or generators, especially if you're working with some confidential data, then better not to use them. But that's the great feature of XMLs, that we have this support for schemas and data types. Support for schemas. So finally, we can define that, let's say this salary column is a number. In case of CSV, we weren't able to do this. Support for schemas and data types. And data types. Now, even if we don't have a schema for our file, we can check whether a given file is a well-formed XML. And there are some basic rules that we could use to validate our file. For example, well-formed XML should have a closing tag for every opening tag. So for example, if we use lines 1 instead of lines, you will see already in the Visual Studio Code this squiggly line that tells that there is something wrong with our file, that we don't have this end tag for our lines element. Likewise, if we had multiple root elements, those top level elements, again, it will complain that actually there can be only one root inside our XML, only one parent. Now, when it comes to XMLs, what we can also have is something called prologue or XML declaration that specifies what encoding is used to store our data. Again, this is important to properly handle all those characters. And actually, I remember a case when I was processing a file that contained some strange characters. Like I had a product name, like super product, and at the end of this name, you had this trademark symbol. And now, when I used incorrect encoding to parse the file, this TM, it became some gibberish, some dummy data. It wasn't decoded properly. The same I had in cases where I had some sales orders that could be gifted to some recipient, and the person who was creating the order could write some dedication that would be printed and added to this gift. And quite often, those buyers, they used various emojis that again were encoded in a specific way, and if they were not properly decoded, then this gift message would become a trash. So yes, encoding is pretty important. Now, if you look at this XML file, you will see that actually it is quite lengthy by those tags. That actually the values that we care about are a small part of the file, and the remaining parts are those tags, this opening tag and end tag. So that's a common complaint about XML files, that actually they are quite lengthy. Length. And let me just write something that I discussed earlier, is this well-formed XML. So the file that has matching start and end tags, single root elements, and so on, versus a valid XML. And the valid XML is a file that conforms to the schema. And in case of XMLs, they are mainly used by various APIs or data that are sent between some systems by APIs. For example, in the past, I was working with Beanstalk, and it worked on XML files. So basically, that's XML. And there's much more that we could talk about XMLs, but at this point, I just want you to be able to recognize XML when you say it. So that's how XML looks like. Now, the last file type I would like to talk today about is JSON. So JSON stands for JavaScript Object Notation. JavaScript Object Notation. And you could treat it as a successor of XML. Because you should remember that XML is lengthy, that it takes a lot of space because of those tags. And even though it's easy to understand, then JSON was meant to be even more easier to understand. And again, like XMLs, it supports hierarchical structures. Hierarchical. It's easy to understand, and I will show you that in a second. Easy to understand. All right, so let me create some JSON sample. So in case of JSONs, we no longer have those tags. Instead, we work with objects and arrays, basically. So let's say that you would like to create something similar we had in case of XML. So we would have an order. So we would create this order element. That would be a JSON object. Those curly braces, they mean an object. What we had in case of our XML, we had this header and ID equal to 1. So we might have ID property set to 1. Then we might have this header object that would again be a JSON. And what we had was order date and comments, like order date, like this, and some comments. Super product. And you should already see some pattern that in case of JSON, we have a name like this ID, and then a value like 1. And now the value doesn't have to be a primitive value. No, it can be also a JSON element, like we have in case of header. So header is the name, and the value is actually this nested JSON. Then what we had was those lines. So we might define another lines element, but this time we would like to have an array, and those square brackets, they mean that we will be working with arrays. And what we had here was lines. So let's say we have a line number 1, the first line. We had product ID equal to 1. We had unit price and quantity. Yeah, we had quantity free. We might have unit price equal to 10. And then let's create another object inside our array. Let's say product ID 2, quantity 31, unit price 1. And then one more, product ID 3, 12, and so on. So that's how JSON looks like. And please compare it visually with XML. So that's the XML with those opening and closing tags, and the JSON, which is much more concise. So it's it's more lightweight format compared to XMLs. And it should be also more easy for you, for humans, to read JSON compared to XMLs, because of the lack of those tags that might clutter the file and make it more difficult to understand. There's JSON. Just by looking at it, it should be quite easy for you to see what data it contains. But basically those two formats, they store the same data. Now, so JSON is easy to understand. Again, it is used widely by various APIs. And basically nowadays, when you are connecting to some API, there is a pretty high chance that you will get JSON as your data. It's easy to be read. It doesn't have tags, so no tags. It is lightweight compared to XML. So the same set of data, it will take less disk space compared to XML. And likewise, like in XMLs, there is support for schemas, like JSON schema. And you can use, again, some online validator to check your file against some schema. But again, we are not diving deep into those files, into operations you could perform on them. What I want you to be able to do after this session is to recognize CSV, XML, and JSON when you see them. And then you would know more or less how to work with them. And in case of CSVs, you should remember about this metadata stuff that is really important before you start ingesting your files. All right, one more thing before we end. Those three file types, for sure you will encounter in your data engineer career, but are they a good choice for storing data in a data lake? Do they support those analytical queries when we would like to read only a part of the file, to retrieve only a single column, like a month column? Not really. Do they support, or do they compress well, just to save disk space? No. So even though you will be ingesting those files, CSVs and JSONs for sure, then it doesn't mean that we should use those formats on our data lake. There are better file types that we should use inside our data lakes. But that's something that we'll cover on a future episode. All right, so that was it. Thanks for today and see you soon. Take care.